Later in the episode,
We had lasers that were literally 40 feet long, that were infrared, that would blow holes in walls. We had others that were, even the one that was low power that we were using on the goggles, took up a bench that was probably about 12 feet long.
howdy folks, welcome to STEMming the Unknown, a podcast that inspires high school and early college students starting out in STEM and research. I'm your host, Dave Tomac, and today we have the one and only Dr. Caldwell. Dr. Caldwell worked as a professor at New Mexico State University and the University of the Virgin Islands for 12 years, teaching chemistry and conducting research. She also worked for NASA, where she studied the atmosphere of Titan, the effects of lasers proposed by the Reagan administration, and finally conducting research for the military, where she observed the significance of the use of lasers as a way to detect troops at night. Dr. Caldwell now serves at the University of Connecticut as a professor in residence, focusing on developing research projects for upper-class chemistry majors. Welcome to the podcast, Dr. Caldwell.
Hi, thank you for having me.
So the first question for someone that works in chemistry and in physics, why did you choose those two subjects specifically out of everything in STEM?
Hard to answer. Science was always my goal. I don't like engineering that much. Engineering is a more practical aspect of science. I liked the imagination and where could you go with research of science. I do love math, but I couldn't imagine doing it for the rest of my life. And so when it came to science, what are your choices? Biology, chemistry, physics? And I do not like biology. I'm sorry. I don't want to study cells. I don't want to memorize bones and muscles in the body. Chemistry and physics allowed me to do a lot of the things that I probably could have done as an engineer, building little projects, but then using those projects, not building them for somebody else.
And I wanted to ask, I remember you mentioned this in a previous interview. I just love the story. How did you get into chemistry?
8 years old, my parents bought me a chemistry set. My best friend's dad was a chemistry teacher. He supplemented it, and I completely ignored all the rules that said do not mix anything unless you specifically have it written out in this booklet. I mixed some things and I blew a hole in the base of my wall. Luckily, I had a very cool mother.
I also wanted to ask, so you went to college at 16. Mm-hmm. You started studying chemistry, and you then went on to do a PhD in physics, if I'm correct.
It's a double major in physical chemistry and astrophysics.
How did you feel going into college at 16? Because that's kind of a young... I remember I came into college at 17, and I was like, oof, I'm surrounded by people that are a year older than me.
It was scary, because people were older than me. And it became very obvious that people were older than me, because back then the drinking age was still only 18. Mm-hmm. And the person I had teaching Gen Chem 1, my first semester in school, liked to hold his discussions in the beer garden on Fridays at 5 o'clock. And at 16, I was not allowed in the beer garden. So it became very obvious at a very early part that I was very young. I basically stopped telling people I was 16 and just tried to do my best to fit in with everybody else.
Were there a lot of 16-year-olds at that time?
I don't know that there was another 16-year-old anywhere in my freshman class. If there was, I never met them.
Yeah, that sounds a little intimidating, to say the least. So, throughout your undergrad, was there any moment that you were like, I'm choosing the right path? Or were there moments where you were like, do I really want to go into chemistry? Do I really want to do math and that type of stuff?
The very first semester, despite the fact that he wanted to have his discussions in the beer garden, I loved my Gen Chem professor. He made chemistry fun. He was doing research on the geology of the moon, studying some of the moon rocks from the Apollo missions. He made everything sound really fun. Second semester, I got your traditional guy who looks like Bill Nye the Science Guy in his white coat and his bow tie, and he talked in a monotone, and it drove me crazy. Mm-hmm. That same semester, I had physics, and it was team taught, And one was always lecturing while the other one was doing demos in the background. And
Right.
I thought, well, maybe I might want to go into physics. I always loved math. I took 7 semesters of calculus and a semester of linear algebra in college, but I never did want to go into math at all. I knew that wasn't something I wanted to spend the rest of my life doing. The one stumbling block as to whether or not I wanted to be a chemistry major or whether I should switch to physics or whether I should switch to something else entirely was that URI had a 3rd semester of organic, which is very unusual. Most schools don't have it. Mm-hmm. And I had a professor who told me flat out girls belonged in home ec. I struggled through the class and I flunked it first time around. I was the only female in the class and he was unwilling to help me. He was the only one who taught the class, so I had to retake it the next year because I had to have it to graduate. Luckily, there were several other females in the class, so he couldn't really pinpoint all of us. But it made me wonder if I wanted to go into a field with a bunch of old white guys that didn't like females or anybody that was different from them. But I struggled through, made it through, and I'm happy with the choice.
Did you ever have that come up again when you were doing research, when you were working for any government organization or something like that, where you had that same type of attitude?
I got it from one of the professors in grad school, but working, I never really saw it. At one point in my career when I was doing assessments for the military, I was in a building where I was the only female in the entire building. It didn't bother me, didn't seem to bother the guys. Sometimes things came up that were external to everything. When I was working, I took a year and a half off between undergrad and graduate school, and I was hired to work in an quality control analytical lab for a company in Rhode Island, and they hired me for the midnight to 8 a.m. shift. It was me alone in the lab and 6 or 8 guys out on the floor. It was quiet, the guys were nice, I had no problem, and someone reported it and said she should not be there alone with just a bunch of guys. They pulled me off. They wanted me to do the 4 to 8 or 4 to midnight, and I refused. So they put me on days where they didn't need me. I was wasted. And when I told them I was quitting, they said, oh, well, you can have the midnight to 8 a.m. shift back because the guy that we hired is incompetent. And I was like, but you shouldn't have fired me in the first place. You shouldn't have moved me. And it had nothing to do with anybody I worked with. It had nothing to do with myself. Somebody in HR decided that that was inappropriate.
Right.
But working for the military, I grew up in a military family. You just got to learn how to handle some of these military guys when you're working for the military.
So I do want to kind of pivot a little bit. So when you were working at NASA, around what period of time did you work for them, and then how was that experience conducting research for them?
I worked for them for the year before the shuttle blew up in 1986. I loved it. I loved being, I was teaching at Cal State Northridge and doing my research for NASA. I loved the camaraderie there was with NASA. Everybody would get so excited about the project that we were working on. I really enjoyed that. It was something that I had hoped to do for the rest of my life. And then the shuttle blew up, and at least a third, if not half, of everybody working at the Jet Propulsion Lab ended up losing their jobs or getting transferred someplace else. Things were just not good. And so I stepped down and found something else to do.
So when you were working at NASA, where they were getting the biggest budget they've ever gotten, how did that impact projects and things that you were doing there?
It was great. With a budget, you can come up with all sorts of ideas as to where you can send a probe and what you're going to do and what do you want to study. There were just so many ideas floating around at that point because there was money and there was excitement as to space. What are we going to find out there? When the budget gets cut and they're like, we don't need space exploration, we're fine. It's a very different type of environment. Right. And we still have fun stuff. When they land a probe on the asteroid like they did last year, that was a huge excitement for people at NASA. But it's taken a long time to get back to that. It really has.
What do you think causes that? Is it like a lack of projects, a lack of television, or like televised broadcasts?
Well, at first, the money was because the Russians launched Sputnik. So we had to beat them. Then there was the excitement of landing on the moon. And then they started talking about, oh, well, we're going to go to Mars next. Instead, they developed the space shuttles. And the space shuttles, I'm sorry to say, were boring. They went up, they orbited the Earth, they did science experiments that most people on Earth had no idea what they were doing or why they were doing. And the average public got disinterested. When the public gets disinterested, then the government gets disinterested. And it's like, well, why should we do these sorts of things? So a lot of the exploration that had been done in the 60s and 70s wasn't being done, and what was being done wasn't exciting enough that when the shuttle blew up, it's really not surprising that a lot of the money got cut because there wasn't the excitement of exploration anymore. The mission I was working on to go to Saturn, it got postponed for 17 years until somebody decided it was going to be fun to do it again. And we're just starting to get back now to the idea of exploring things, but some of that doesn't come from the government. Some of it comes from private industry that wants to send people to Mars whether they have transportation back or not. So the excitement is starting to come back, but it's taken a long time.
So you also mentioned the research that you did for NASA. You obviously did a lot of different things for them. Can you talk about some of the projects that you've done?
Back in the 80s, Reagan had this idea that this is the project I moved to after I worked on the Cassini mission. So for Titan, I was actually modeling the chemistry of the atmosphere because they were going to drop a probe to the surface of Titan. Titan has a very thick atmosphere, and it was believed that at the surface, ethane gas might work like water does here, where it might be liquid, it might make clouds, it might rain. So we were looking at that. When that got finished, I went to work for Reagan's Star Wars Defense Initiative, where the idea was we would take lasers and shoot down Russian drones. When I was originally hired, the idea was to study what happens to the Earth's atmosphere when we shoot a laser through it. And we literally burn holes in the atmosphere every time we shoot a laser, whether it's inside a lab or it's outside. We burn holes in the atmosphere. And so I was studying how we do that. That went on for several years and basically went nowhere because it was discovered it's really hard to shoot down a drone with a laser. No matter how strong. I mean, we could blow holes in walls with the lasers that we had, but it's really hard to shoot down a drone. So that kind of got put aside, and then Desert Storm came in, and the U.S. was at war, which it hadn't been for a while, and the question was, how do you detect the enemy? And we had learned in Vietnam that it was really hard to detect the enemy in a jungle. Well, Desert Storm told us it's really hard to detect the enemy even in a desert where everything appears to be wide open. So we were using some of our less powered lasers and doing sweeps and determining whether or not we could pick up the night vision goggles by sweeping with a laser. An infrared laser, so nobody's going to see it, but you could get a reflection back. So it was a way to detect the enemy, and it was also to help develop our own non-reflective night vision goggles, so nobody could come back and find us in the dark. So I did that for several years as well. There's all sorts of strange things that the government will ask you to do. I would have preferred space, but since that fell apart, I love to play with lasers. They're fun.
What about lasers really excited you?
You've never played with a laser?
I've done it with my cats, yeah.
Well, now imagine that on a scale about 100,000 times bigger.
Right.
We had lasers that were literally 40 feet long, that were infrared, that would blow holes in walls. We had others that were, even the one that was low power that we were using on the goggles, took up a bench that was probably about 12 feet long and produced this really pretty bluish purple color till you tuned it to get it to the infrared. Its original color was this blue, and then you use some of the harmonics to get other colors. We had several different lasers that we were using, and they're just fun to play with. They make pretty colors. You can do all sorts of weird things with them. I've worked with ones that were visible light. I've worked with bluish ones. I've worked with red ones. I've worked with some greenish ones. I've worked with infrared ones that you can't see. Once you get past the fact that they're really hard to get your laser beam to point where you want it to, they're a lot of fun to play with.
You also mentioned in a previous interview that you much prefer teaching to research.
Now I do, yes.
Why is that?
Well, when I got married 20 years ago, I was working for the University of the Virgin Islands, doing 2 different research projects, one student-led and one of my own. I got married and I had a child, and the child ended up with health issues. And research takes a lot of time and effort. And it isn't always satisfying. You know, working for the military isn't always satisfying. You don't get ends to things. Teaching, if I can get a student who's scared of chemistry to enjoy the class, or if I can get a student who's barely making it in class to study and get them a good grade to pass the class, there's a satisfaction to that you don't get in some of these other jobs, whether it's industry or the military or the government, NASA. There's a real satisfaction to that.
To pivot slightly, would you also agree that while demanding and occasionally unsatisfying, conducting research has its exciting moments? I'm asking because I recall the first moment I was involved in a study's data collection, how significant that moment was to me, to know that you were discovering something for the first time.
No, it's nice to do publications. I have a lab that we've spent some money on getting new instrumentation. And just last week, we did some studies. We were making polymer gels. Polymers are really big here on the UNKOWN campus. We were making polymer gels, and we were doing studies to determine whether or not they were crystallized or whether they were completely random. And one of the students made a polymer gel that was 58% crystallized, and when we put it under a surface instrument, you could see the lines of the polymer lining up right next to each other. And that's really cool. So, you know, that's something that eventually, if we can get some good results from, is something that we can get a paper out of.
How is it to work with, for lack of a better term, the next generation of students?
They are the next generation because they're about the same age as my daughter is. So it is the next generation. Getting students excited, getting them into something that they think is going to be something they want to do for the rest of their life. It's fun to watch them mature into scientists. One of the things we do in the senior level class is require them to develop their own project. So it's interesting to see how they approach science. Right. And the ways that they think they can improve the world in general.
So what advice would you give to students starting out in research and possibly are considering chemistry or physics as a starting point?
Find something you love. When I applied to grad school, I only applied to 3 schools. One said they weren't accepting anybody but orgo people, and I'm not an organic person. One never responded to me, but I got into my top choice because I knew exactly what I wanted to do, and they had the opportunity to do it. Find somebody who you think you would want to work with, somebody who's doing the kinds of things you think you might like. And if you find out after a while you don't like that, then find somebody else. You've got to find your passion. It can be hard. The fact that we expect people at 18 to go to college and have a clue what they want to do, and have them graduate at 22 and have a clue what they want to do, is difficult. I mean, I took a year and a half off between undergrad and grad school simply because I needed to focus in my head as to whether or not this was exactly what I wanted to do. And if you don't know, then 5 years in grad school is going to be the most miserable time of your life.
So it's actually really interesting that you bring that up. I talked to a few professors, researchers, and experts in the field that have moved past the stage of grad school. And the ones that tended to take opportunities that they thought would benefit their career over opportunities that they thought they would themselves enjoy tended to have a really unhappy time in grad school. I was also meaning to ask, for the population of our audience that consists of high school students and early college students that are just getting started in STEM and in research, what advice would you tell them specifically compared to a student that's entering grad school?
First of all, it depends on where you live.
Mm-hmm.
My daughter started research when she was a junior, but she also attended a high school that was on a university campus. So she had that advantage. But if you aren't, there's a lot of resources out there nowadays. There's people you can see on YouTube that are doing things. There are lots of educational sites that will tell you how to do things.
I'll also give a quick shout out to our website, Research Resource Media. We're working very hard to build up that collection of resources for people that are interested in starting out in STEM and research.
JChemEd, the Journal of Chemistry Education, will publish, these are fun things that you could do. Now, not everything can be done at home or done without a lab, but they, offer some things. The ACS has an entire page for high school students and offers some ideas as to some things to do. I homeschooled my daughter. We just blew things up in the driveway. Carolina Biological offers kits for things for both chemistry and biology. You have to be careful which ones they'll sell you, because some they will not sell to people that are not affiliated with a specific school. But they do have things for homeschoolers. There are a lot of science kits out there for homeschoolers. Years ago, when I was at New Mexico State, New Mexico State has several branch campuses. We're a rural state, and so there's a lot of people who are hundreds of miles away from a campus. And so the rural areas, the branch campuses were starting to offer online. And I was told we needed to develop an online program to compete. And I looked into it. For $300 or $400, you can buy a chemistry kit that's equivalent to what you would use in a real science class. I don't recommend them because they'll have toxic stuff in there and not tell you anything about how to dispose of things.
Right.
But I found a number of things that were, at home kind of things that you could do. Things you could do with stuff you could buy at Walmart. So there's, depending on what you want to do, even if you don't have access to a university or your high school doesn't have a really good lab, you can find things online and try things out. See what it's like to do some of these things. Do you enjoy doing this type of thing or this type of thing? Thank you, Carolina Biological. There are a lot of resources out there. And if you don't have access to a person that can help you or a school that can help you, just finding your own stuff online is now easy to do.
I remember when I was in high school, I didn't have any access because we weren't a high school that primarily focused in science. And I had to keep looking at other places that would take someone that was in high school. At the time, I was a sophomore, I think. And I got a really cool job at a local botanical, historical, and research site. And we did, so many cool things. I got to do, water testing and, we used, different probes and stuff to do. So it was really, that's kind of, not a caveat, but I guess in addition to...
No, remember, high school students, you have June, July, and August off.
Right, you have a whole summer, yeah.
There's stuff out there. If you're interested in, for example, aquatics, Mystic Aquarium takes interns over the summer. If you're interested in the historical aspects, you can do some of the historical museums. If you're interested in some of the other things, the Hartford Science Museum. And for people who are not here, look at the resources you have. Do you have science museums? Do you have botanical gardens? Because a lot of those places will take summer interns. You might not get paid for it, so if you want to make money while you're in high school, it might not be the best thing to do. But there are opportunities out there. You just may have to hunt for them.
And I will also say that a lot of institutions are creating programs that excite youth.
Last year, a high school teacher came in and took a whole bunch of equipment out of my senior lab for a summer project that they were doing. They were studying aquatic stuff. My daughter did a summer one where she went out and collected bugs in the rivers. There's a lot more available now than there was. I mean, I not saying I didn't do it. I belonged to a group that was run by a retired physics professor who had basically a physics lab in his basement. And I was there in high school doing some research. Sometimes you can just find somebody that is doing things on their own. They just may have retired and want to keep doing something in their field.
Right. So we're right about out of time. I want to thank Dr. Caldwell for joining us today. And if anyone has any questions about today's podcast, please feel free to reach us on the Contact Us page on our website. We will see you in the next episode.